Hello class, welcome to Unit 5 Video 4. Today we're going to look at multiplying probabilities. The learning target is that you can solve problems involving compound independent and compound dependent events. Okay, so we're going to be looking at them, and when they're compound, that's when we go ahead and use multiplying with our probabilities. So what is a compound event? Okay, it's an event made up of two or more events that can happen either at the same time or one after another. Okay, so we're going to first look at independent, then we'll look at dependent events. So two events, A and B, are independent if one event happening has no effect on whether or not the other event happens. Okay, so what that means is, for instance, I roll a dice and I spin a spinner. What happens on either one of those does not affect each other. Another good option is I draw cards from a deck. I draw a card, I look at it, and then I put it back in the deck, and then I draw another one. Since I put it back, it doesn't affect my second draw, so they're independent. Okay, so the probability of A and B happening, okay, biggest thing here is and, that's going to tell me to multiply, is the probability of A happening times the probability of B happening. So biggest thing you need to remember is that whenever you see the word and, multiply. Okay. So example 1, Julio reaches into an ice-filled cooler containing 8 regular soft drinks and 5 diet soft drinks. He removes a can and then decides he is not really thirsty and puts it back. What is the probability that Julio and the next person to reach into the cooler both randomly select a regular soft drink? Okay, this is independent, and the reason it is independent is because he puts the can back. Okay, if he didn't put the can back, then it would be considered dependent. So it's independent. So he reaches in and he grabs one. So we want to know the probability that he gets a regular, and the next person gets a regular. So what's the probability that Julio gets a regular? Well, the first thing I would know is how many total cans are there. There's a total of 13. And how many regular are there? There's 8 out of 13. So here is Julio. Okay, now the next person, some other person, is going to draw a can. He put the can back, so there's 8 out of 13 available for that person as well. And if they're both going to happen, it's one after another, you're going to multiply those events. And so you'll get 64 over 169. And then I would go ahead and reduce that. So if you wanted to know what it was reduced, 64 divided by 169. You go math, frac, enter, and it doesn't reduce, so that is my reduced fraction. So this would be my answer, and I would provide the decimal. You can just choose one, so it's 0.379, either reduced or the decimal. To 3 decimal places, please. All right, that's example 1. Example 2. In a state lottery game, each of 3 cages contains 10 balls. The balls are each labeled with one of the digits, 0 through 9. What is the probability that the first 2 balls drawn will be even and the third will be a prime? Okay, so what we want to know is the probability of being even, and then a prime. Okay, the first thing I want to know is, how do I know it's independent? So everybody see how there's 3 cages? So I'm only taking 1 ball from each cage, and so what I get from the one cage will not affect what happens in the next cage. Okay, so there's 10 balls in the cage, and it's from 0 to 9. How many numbers are there from 0 to 9? Well, if you count them out, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 10 numbers. Okay, and how many of them will be even? That's half of them. So to be even, it's 5 out of 10. Then to be even again, so times 5 out of 10, times, now from 0 to 9, how many are prime? Remember, to be prime, you can only be divisible by yourself in 1. Okay, so there is 2, 3, 5, and 7. So there are 4 primes, 4 out of 10. Okay, I would recommend, if you can, reducing these right away. So it's 1/2 times 1/2 times 2 over 5. Notice these 2's will cancel. So I'm left with 1 over 10, or that's 0.1. Okay, so there is my example 2. If you have any questions, feel free to write them down. Come and ask on independent events. Now we're going to look at dependent. So here's how it works. compound events can be either independent or dependent. And remember, compound is one happening after another. So it breaks down either independent or dependent. So remember, independent is when the outcome of one event does not influence the outcome of a second. Dependent is when it does influence the outcome of the second event. So once again, independent, I draw a card, I look at it, I put it back. Dependent, I draw a card, I hang on to it, then I draw another card. Okay, so that's the difference between independent and dependent. So, example 3, determine whether each pair of events is independent or dependent. Okay, tossing a coin and rolling a die. Does one affect the other? No, so that would make it independent. Okay, selecting a red apple and then a green apple from a bag of 6 red and 4 green if no apples are returned to the bag after being selected. Okay, if it's not returned, then it is dependent. And C, same problem except for if the first apple is returned. So if it's returned, that makes it independent. Okay, as we go through, I think independent and dependent will become a little more clear to you. But let's look at how do we find the probability of dependent events. Okay, so when two events are dependent, the conditional probability of an event B in a relationship to an event A is the probability that the event B occurs given that A has already occurred. Okay, so the wording gets a little confusing, but once again, still have that and, so it's going to be multiply. You figure out the probability of A, and then you'd figure out, well, what are my chances if A does happen to figure out B? So let's just look at an example. It's probably the easiest way. Find the probability of drawing 3 cards of the same suit from a standard deck without replacement. That without replacement right away tells me dependent. Okay, so same suit. Okay, finding the probability. How many cards are in a suit? There's 13 out of 52. If I am saying that I want a card from that suit, that means I have a card in my hand that is that suit. So how many cards do I have left to choose from? There's only going to be 12. Out of how many total cards? Now there's only 51. So that is how a dependent, and I'm doing 3 cards of the same suit. So now I have 2 cards of the same suit in my hand. Okay, and so how many cards do I have to choose from? So there's 2 less of these, so there's 11, and now there's 2 less total cards out of 50. Okay. And the trick with this one is I would say, how many suits are there to choose from? Well, there's hearts, diamonds, clubs, and spades. So there's 4 suits, so we have to include that in our probability. So multiply it by 4, because there is 4 suits. So if I go ahead and multiply this out, I get 6,864 over 132,600. Which is 22 over 425 reduced, and as a decimal, it's 0.052. So there is example 4. Okay. Now, we're going to move on to mixed events. So we have to determine if they are independent or dependent. Okay. So example A, 3 cards are drawn from a standard deck without replacement. Okay. As soon as I hear that they're not replaced, I know dependent. Okay, find the probability of drawing a heart, another heart, and a spade in that order. Okay, so we want probability of a heart, and then a spade. I can't draw them very well. So spade, and it says in that order, so I don't have to worry about, what order could they be in. So heart, and then a spade. Well, how many hearts are there? Okay, there's 13 hearts out of 52. So now it's saying I have a heart in my hand, okay, and I'm going to draw another card. How many hearts are there left? There's 12. Out of how many cards? 51. Now I'm moving to a spade. Okay, well, I have 2 hearts in my hand, so that means all 13 spades are left in the deck. Out of how many total cards? 50. Okay, if I multiply this one on my calculator, I'll just walk you through how to do that. You would do 13 divided by 52 times 12 divided by 51 times 13 divided by 50. Okay, you'll get the decimal, and if you want your reduced fraction, you go math, frac, enter, and there it is, 13 out of 850. Is that what that says? So 13 out of 850, and as a decimal, that was 0.015. The 2 tells me it stays, so equals 0.015. All right, so there is example A. B, spin a spinner numbered 1 to 7 and toss a coin. Okay. Does what I get on my spinner affect what happens on my coin? No. So right away, I know independent. What is the probability of getting an odd on the spinner and a tail on the coin? So I want probability of getting an odd and then a tail. Okay, my spinner is 1 to 7, so my odds are 1, 3, 5, and 7 out of how many total? From 1 to 7, there's there's 7 numbers, so there's 4 out of 7 to be odd. Times, to get a tail on a coin, there's a 1 out of 2. So this gives me 4 over 14, just multiplying across. They're both divisible by 2, so I get 2 out of 7, or as a decimal, it's 0.286. Okay, that is example B. C. You reach your hand into a bag of Scrabble tiles. The bag has 1 tile with each letter. You pull out the first 1 tile and then another. What is the probability that you will pull out a vowel and a consonant? Okay, did they specify that it was returned? No, so dependent. Vowels, remember, are A, E, I, O, U, and so how many vowels are there? If there's only each letter, so there's 26 letters in the alphabet, so there's 5 vowels. How many consonants? 26 minus 5 is 21, so there's 21 consonants. So we want the probability that you will first 1 tile and then another. So we want to get a vowel and then a consonant. So how many vowels are there? There's 5 out of 26. I am not returning it, so I know I have 25 to choose from, but I still have all the consonants to choose from, so I have 21. And this will give me, if I multiply and reduce, 21 over 130, which as a decimal is 0.162. Okay. Moving on to D. A card is chosen at random from a standard deck of 52 playing cards without replacing it. So we are not replacing it, so right away I know dependent. A second card is chosen. What is the probability that the first card chosen is a queen and the second card chosen is a jack? So we want the probability of being a queen, and then we want the probability of being a jack. Okay, so how many queens are there? There's 4 out of 52. Times, now I have a card still in my hand, so there's only 51 total. How many jacks are there? There's still 4. So if I multiply this out and reduce, I get 4 over 663. And as a decimal, that is what is that one as a decimal? 4 divided by 663, 0.006. All right, and there is example D. Last one, E. 4 cards are chosen from random with replacement, so that means they're putting them back, so it tells me independent. What is the probability of choosing 4 hearts in a row? Okay, so we want the probability of getting a heart, and then another heart, and then another heart, and then another heart. Well, to get a heart, there are 13 hearts. It's 1 suit out of 52. To get a heart again, if I put it back, I still have a 13 out of 52 chance. And again, and on my first time. So this is 13 out of 52 to the 4th. You could type it in that way. When you type it in and reduce, you get 1 over 256, which is, as a decimal, that's a 6. 0.00, this is a 9, so it tells me to round up. 0.004. So either one of those is perfectly fine as an answer. All right, so that will be the end of Unit 5, Video 4. If you have any questions, please let me know. Otherwise, have a great day.